All right, let's go ahead and do two problems involving hypothesis tests with proportions. And let's take a look at these problems. I went ahead and put them together because they're so related that it makes sense to do this. So let me go ahead and share that with you. So these are the two problems that we're going to be working on here. And start number 35. It says in a clinical study of an allergy drug, 108 of the 202 subjects reported experiencing significant relief from their symptoms. At the 0.01 significance level, test claimed that more than half of all those using the drug experienced relief. Identify the null hypothesis, alternative hypothesis, test statistic, p-value, conclusion about the null hypothesis, and final conclusion that addresses the original claim. So there's quite a bit there, but I think we can take care of a lot of it pretty quickly. So the null hypothesis. The null hypothesis is that P, which is the proportion, gotta look at the claim. Just a claim that more than half of those using the drug experience relief. So that's actually gonna be the alternative hypothesis. So P is more than 0.5. So that means that the null hypothesis is that actually P is 0.5 or equal to half. Okay, and then so that takes care of the null hypothesis, the alternative hypothesis. The test statistic is going to come from this value. So we'll go ahead and call it P hat, which is going to be 108 divided by 202. And I'll go ahead and put that in my calculator. Don't need to share that from the calculator. It's just 108 divided by 202. 108 divided by 202. So I'm getting 0.5347. I'm trying to round off to 4 decimal places. At this point, it's better to round off as far as you can. And then, okay, so now we have to figure out what the p-value and then the conclusion. We'll do these other pieces one at a time. All right, so we're gonna go ahead and go into the calculator now. So let me go ahead and share the calculator with you. And what we're going to do is we're going to go to stat. And we're going to go to the tests. And specifically, we're going to go to a one proportion z-test. That's number 5. Okay, so our p hat is the same as their p0. So that's going to be 0.50. And then the x, I'll just go back to the problem. It's 108. And the n is 202. So 108 and 202. They don't ask you, actually the 0.5 is not p hat. P0 is just the P that we identified. And then this is a one-tailed test. And so the alternative hypothesis is that P or P0 is greater than 0.5. So it's a right-tailed test. Okay, and I think we're ready to calculate. All right, our P value is 0.1623. .1623. So our P value is 0.1623, which is greater than our alpha, which is 0.01. Therefore, there is not, this would be the conclusion, there is not enough evidence to reject the null hypothesis. We cannot reject the null hypothesis. I'm not going to write that down. I'll just state that. Cannot reject the null hypothesis. There is not enough evidence to conclude that the true proportion is not half. Therefore, we cannot support this claim. Now, on the other one, it's very similar. So it's good to make note of the null hypothesis, the alternative hypothesis, and we'll write down the N and the X here in a minute. But we want to test the claim that the proportion of all adults in town that have been exposed to this strain of flu is 8%. So is 8%. That's the null hypothesis. So the proportion is, and they're using P0, so we'll use P0, is 0.08. So the alternative is that P0 is not equal to 0.08. And the N is 47. Oops. N is 47 and X is 9. And they don't give us a significance level, which should be fine because we're not required to put one in. We can simply report the p-value, and that's often done in scientific papers. Sometimes they don't choose a significance level, they just report the p-values. Okay, so let's go ahead and go to the calculator. Let's go back to the main screen here. And so we're going to go to stat. It's a one proportion z-test as well. So the same test. This time P0 is 0.08. X is 9. N is 47. And the only, one of the more important differences is that this is a two-tailed test. And so go ahead and run it. And this time our p-value is 0.00484. So our p-value is 0.00484. And that's all they ask us to report. They don't ask us to do any interpretation. So these are two problems involving hypothesis testing of a proportion.